Solution from problem J. So this is a flow problem. We first need to observe that the viscosity doesn't play much role, because we can divide the flow of the flubber by viscosity, and that only affects the optimal function in a multiplicative constant. Now we take a look at each commodity by itself. So we construct a flow from the water source to sink to find out how much water we can possibly get through the pipes. We do the same for flubber, and then we do the same for both commodities at once. We do this by creating an extra vertex that acts as a source with infinite capacity edges. Now we have found out three constraints for the amount of water, flubber, and both at the same time. And we need to find the amount that maximizes this objective function. It can be easily shown that this has to lie on this line segment, and it is either one of those endpoints or some point in the middle. We can find this by ternary search, but there is also a closed form solution. And now that we know the amount of water and flubber, we just need to construct the flow. To make sure that we don't violate the property of water and flubber not flowing in the opposite directions, we first construct the flow that maximizes the amount of water and flubber together. And then what we can do is we simply reduce the capacities of each edge to be the same as the flow value. And then we send in this new graph, then we only send the flow of flubber to the source. And this ensures that this property is not violated.